Okay, so now we know how to find out what the gradient of a straight line is. So if I have a straight line like this within a number plane, I can easily find its gradient by finding out basically what's the change in its y-axis and what's the change in its x-axis. We can find that delta y. We can call them delta y and delta x, which means change in the y direction and then change in the x direction. Okay, but we actually call that rate of change. So another name for gradient is rate of change. So rate of change basically tells you what is the change in y-axis versus the change in x. So this is basically a linear rate of change. However, what you see in reality and in most cases in life, rate of change isn't a constant. So that is a constant. So as we said before, no matter where you choose your 2 points, the gradient of this line is always going to be the same. So it's always m, which is your rise over run. Okay, so that's a constant. And by constant, we mean that it's going to be the same everywhere. However, most rates of change in reality are something like this. Now you can see that this is not a linear function. The importance of that is that the gradient or the rate of change of this graph actually changes from each position, from one location to the other. So if I wanted to see how the gradient of this graph is changing, what I do is I just start drawing lines. So the lines that I draw will actually only touch this at one point. Okay, so let's say at that point I'll draw another line. That point, we call these lines tangents. So tangents by definition are lines that you draw and they only touch your graph at one point and no other point. Okay, so they're basically linear functions, so they're no different to this line that you have here. So if you continue doing that, what you'll see is that now you have just constant lines that are drawn on this graph. So for example, here on this line, you can see that that's the kind of gradients that it has. Okay, and we said before that this is the shape of a positive gradient. So we know that on this, at this point, the gradient of this graph is positive. And the same at that point and that point. And you can see that from all the way from there to there, your gradient is always positive. Now when you get to this point, your gradient is again flat, which means that you have a gradient of 0. Yes? So whenever you're not really, your y value is not changing, then you know that the gradient of that line is going to be 0. Then here, at this point, we have a line which has a negative gradient. Okay, so the gradient of this portion of this graph is negative. Then at this point, you have again a straight line, which means you have a 0 gradient. And then from that point onwards, no matter what kind of line, at what point you draw, it's always going to be a positive gradient. Remember, positive gradients are increasing, negative gradients are decreasing. So in other words, what we can say is basically whenever your graph is increasing, you have positive gradient. Whenever your graph is decreasing, you have a negative gradient. Whenever your graph is changing sides, so see how here it was going down and then it started going up? So then at that point when this change occurs, you will have a negative, you will have a 0 gradient. And same here, your graph was going up, then suddenly it started going down. So at that point, which this change occurs, you will have a 0 gradient.